Assalamualaikum and good day everyone. So today we will continue with the new subtopic, which is 3.2.3 second shift property. If before this we have learned how to solve our Laplace transformation of two functions, that one of the function is exponent by using first shift property. So today we will see the second shift property, where how to find the Laplace transformation of two functions, where one of the function is actually the unit step function u. Okay, so if you have the Laplace transformation of function ft equal to fs and a is a constant, then the Laplace transformation of a two function where one of the function is exponent, one of the function is unit step function t minus a times with other function or any function ft minus a, the formula is exponent e as fs. Okay, where u is a unit step function. Okay, if you have the opposite side of a here, which is if you want to find the Laplace transformation when you have the unit step function t plus a, okay, with any function ft plus a, the formula is just you have the opposite sign, which is exponent es times with fs, where fs is Laplace transformation of the function ft. Okay, what you need to remember is whatever come with your ut plus a is actually ft plus a. Okay, whatever come with ut plus a is actually ft plus a. For example, if you have ut minus 3, okay, t minus 2 to the power of 3 here. Okay, this is two function where the first function is unit step function t minus 3 times with t minus 2 to the power of 3. Okay, so whatever come with ut minus 3 is actually ft minus 3. Okay, whatever come with ut minus 3 is actually ft minus 3. Therefore, you can write your ft minus 3 is equal to t minus 2 to the power of 3. Okay, so another example, if let's say you have u t plus 10 times with exponent 5t squared. Okay, so you need to always remember that whatever come with ut plus 10 here is actually a function of ft plus 10. So if you have been asked your ft plus 10, your ft plus 10 is equal to exponent 5t to the power of 2. Okay, this one is the important things that you need to remember. Whatever come with your ut minus a is actually ft minus a. Whatever come with your ut plus a is actually ft plus a. Okay, so we have a few steps to use when we want to do a second shift theorem. Okay, the first step is you need to find what is the value of a. Okay, so how to know what is the value of a? You can see your value of a from here. Okay, you will have either plus a or minus a. That is your value of a. Okay, from the unit step function itself. The step number 2 is you need to find what is your ft. Okay, because in ut minus a, what you have is ft minus a, but you want what is your ft. Okay, for example, if you have in the function u t minus 3 for t squared, for example, okay, you know that whatever come with your ut minus 3 here is your ut minus 3. Whatever come with your ut minus 3 is ft minus 3. Okay, therefore we have ft minus 3 equal to 4t squared. You don't want ft minus 3. In this step, you need to find what is your ft. Okay, so how to find what is your ft? You need to eliminate your negative 3. How to eliminate your negative 3? You need to plus it with 3, right? Because negative 3 plus 3 is 0. Okay, so It means that whatever t that appear in your equation on the right hand side here, you need to replace it with t plus 3. Okay, therefore what you will have for your ft is equal to 4. Replace t with t plus 3 to the power of 2. Here you have your ft. Okay, another example. Okay, if you have the unit step function u t plus 5 4t square minus 3t, for example. Okay, so you have two functions here. The first function is the unit step function t plus 5, and the second function is 4t square minus 3t. Because one of the function is unit step function, therefore we want to use second shift theorem, and you need to remember that whatever come with ut plus 5 here is actually ft plus 5. Okay, so you can write it as ft plus 5 is equal to the equation here, 4t square minus 3t. In this step, you need to find what is your ft. So to find what is your ft, what you need to do is you need to eliminate plus 5. So how to eliminate plus 5? You need to minus with 5. Therefore, whatever t that appear in this equation, you need to replace it by t minus 5. Okay, so what you will have for your ft is 4 t minus 5 to the power of 2 minus 3 t minus 5. This one is your ft. So for this step, you need to find what is your ft. So next step, step number 3. When you already know what is your ft, you need to find what is the Laplace transformation of your ft, or in the other words, you need to find what is your fs. Okay, you need to know what is your fs. Okay, step number 3. Then you already know what is your fs, you already know what is your value of a. In step number 4, you just need to use the formula where to find the Laplace transformation of ut minus a with function ft minus a. The formula is actually exponent negative as dot with fs. So this is the formula and step number 4. Example 1, where you need to find what is Laplace transformation of the unit step function t minus 4 times with function t minus 4. What the important thing you need to know is whatever comes with your unit step function here, if here you have your unit step function t minus 4, therefore the other function here is actually the function of t minus 4. Okay, so the first step to use the second shift theorem is to find what is the value of a, where the value of a you can find it from here. Your unit step function is step. Okay, so your value of a is equal to negative 4. This one is step number 1. For step number 2, you need to know what is your ft. Okay, from equation here, you have your ft minus 4 is equal to t minus 4. If you want to find ft, you need to eliminate negative 4 here. So to eliminate negative 4, you need to plus with 4. Therefore, whatever t appears in your equation on the right side, you need to replace it by t plus 4. Okay, so what you will have here is replace t with t plus 4. Then you have minus 4 here. Therefore, you have your ft is equal to t. Okay, so this one is step number 2. Step number 3, when you already have your ft equal to t, you need to find what is the Laplace transformation of your ft. Okay, therefore you need to find what is the Laplace transformation of your t. Okay, so your fs is the Laplace transformation of your t, where to find the Laplace transformation of your t, you can use the formula for t to the power of n, where the formula to find its Laplace transformation is equal to n factorial over Sn plus 1. Now here your n is equal to 1. Okay, so your fs is equal to 1 factorial over S1 plus 1 equal to 1 over S to the power of 2. Okay, now you already have your fs. You can move to step number 4, where to find the Laplace transformation of ut minus 4 t minus 4 is equal to exponent as times with fs. So you know already your a is equal to minus 4, therefore you will have exponent negative 4s time with your fs is 1 over s squared. So time with x 1 over s squared. So what you will have is exponent negative 4s over s to the power of 2. So another example here. So let's find the Laplace transformation for unit step function t plus 5 times with t plus 5 to the power of 3. So here you have the unit step function t plus 5, therefore the rest of the function is actually the function of t plus 5. Okay, it must be same like this. If this one is t plus 5, then this is function of t plus 5. Okay, so to use the second shift theorem, the first step is you need to know what is the value of a. So the value of a can be taken from here, therefore your value of a is equal to 5. Okay, so you have your value of a is equal to 5. So next step, step number 2, okay, you need to find what is your ft. Okay, so you know that from your equation you only have your ft plus 5, where your ft plus 5 is equal to t plus 5 to the power of 3. Okay, but now you want to find what is your ft. Okay, so how to find what is your ft? You need to eliminate positive 5 here. To eliminate positive 5, you need to minus with 5. Therefore, whatever t appears in equation on the right side, you need to replace it by t minus 5. Okay, so you have your ft is equal to, replace your t with t minus 5. Okay, so you have t minus 5, f plus 5 to the power of 3. Okay, so now from here you have your ft equal to t minus 5 plus 5 is 0 to the power of 3. So you have your ft is equal to t to the power of 3. Okay, next we can move to the step number 3, where in the step number 3 you have your, you need to find what is your fs, where fs is the Laplace transformation of your ft. Okay, therefore you need to find what is the Laplace transformation of your t to the power of 3 by using the formula n factorial over s n plus 1. Okay, therefore you know that n is equal to 3 here. This one is n. Therefore your fs for this step, fs is equal to 3 factorial over exponent 3 plus 1. Therefore you have 6 exponent 4. You have 6 s to the power of 4. Okay, you have 6 s to the power of 4. Here is your fs. Next we move to step number 4, where in step number 4 you just need to find the Laplace transformation of your u t plus 5 t plus 5 to the power of 3. So it equal to exponent as dot f function of s. Therefore you already have your a is equal to 5, so you have exponent 5s times with 6 over s to the power of 4 as your fs. Therefore your final answer will be 6 exponent 5s over s to the power of 4.